Thank you and good morning. So today I want to talk about unprivileged containers with transient user namespaces and ID mapping, but without SETUID binaries. So yeah, let's just jump in. I mean, just to explain this right, like by unprivileged containers, I mean both nspawn, but also actually all the other stuff as well. I just think that the status quo is bad and we can do much better. And with systemd, I started to do things a little bit better. And that's what I want to talk about. So let's start with Linux user spaces, namespaces, right? Like they have been around for a while. I think they are, from all the namespace types, from all the isolation, probably the most relevant way to isolate containers from each other, in particular full OS containers, because in contrast to all the other container types, such as mount namespaces and so on, they are the ones that actually introduce a security concept, right? Like because they isolate like users from each other and do the mappings to make sure that they do not get to land on each other. So it is the most relevant way to isolate containers, but it had a hard time to actually being adopted in the container environments. And to this day, I think it's not really used in the best way possible. User namespaces are complex beasts, right? Like because you can define arbitrary mappings. They have all kinds of implications how you have to set them up in the right order. They require lots of moving parts right now. Which ones those are, we'll see. There are so many unanswered questions, at least so far, regarding the stickiness of the UID assignments and how these things scale and so on. But as bonus is that supposedly they are unprivileged, right? You're supposed to be able to get a user namespace without any privileges, and then you can run stuff in there. Except, I mean, that's a claim, but it's not really like that. Yeah, it was not, in fact, right. They are not really unprivileged. How does user namespaces work? I assume everybody in this room probably knows this. I've just put this on the slide just for me as a reminder, right? So first you acquire a user namespace with the unshare or clone system calls. Then you configure UID, GID mappings via those files in /proc. You have to do a little bit more, but in essence, that's what it is. So the first step, that's the unprivileged step, right? You can just do this. I mean, not on some Ubuntu versions because I turn it off, but generally the idea is that that's unprivileged. But the second part, that's totally not unprivileged, right? Like you cannot write there. Why can't you write there? Because if you could, without any privileges, you could write mappings to any user you like, and that way get access to inodes you shouldn't be able to get access to. So yeah, they're not unprivileged. The user namespace itself, you can acquire unprivileged, but applying a mapping to it, you cannot. You can, of course, run user namespaces without a mapping, but this is, I think, I mean, it certainly has users, but it's in the general use case is just not there. It's not good enough to run a full-blown OS container or anything like this. So how does this actually work now in the status quo? The solution that most of the big distributions have adopted is around etc subuid and etc sub-gid. The idea is that you have subuid ranges that you delegate to some primary UID for good. I hate that model, but yeah, it basically takes this beautiful design of etc passwd and etc groups, which is, by the way, not beautiful, and extends into delegating whole ranges of subuids to users. And then there is a tool called newuidmap that is a SETUID binary. And if you have been into my talk yesterday, I really don't like SETUID binaries. That populates the UID map and GID map files that I was mentioning earlier from these delegated ranges, right? It's a SETUID binary because, as mentioned, it's a privileged operation. So a container manager that makes use of this always has to shell out to these tools, which acquire root and then do their thing. I would not call that unprivileged. That's very much privileged. Like there's no other way to describe what SETUID is. Yeah, I also don't like shelling out. But yeah, so I don't like anything about it. Like also, it's not really, you know, even if you get delegated a subuid range, there's nothing that tells you how to use it, right? Like which container to assign which of your delegated ranges to. there's no help on this, right? Like there is no actual management of this. So if you run two different container managers, they might as well just use the same ranges, and you might not want that because you want to isolate things. Oh, by the way, if anyone has any questions, again, like on all my talks, always just interrupt me, and we try to get to them right away. So yeah, I would not call all this unprivileged. This is very much privileged. I mean, I know that some other people in the container world always talk about rootless containers. I always found this like, they're not rootless, they're very much rootful, right? Like, because they are SETUID root, that is rootful. So, to summarize, there's so much to dislike, at least from my point of view. I know people disagree. I mean, people on the internet, on LWN even, had these fights and said, oh, SETUID is the best thing in the world. I think it's terrible. Call-out binaries are terrible. What I really hate is the irreversible persistent delegation of subranges, right? Like, because on Unix, if you have a writable file system and you create and you have writes anywhere to create files and you create that file there, then basically this file forever belongs to your user ID, right? So there is no way to, like, if you have a user ID, find out which files are owned by it and delete them all, right? So there is the life cycle. All of this is completely. There's no answer to this, right? What you would have to do to find all those files is go through the entire file system, look at every single inode, and then delete that. But that's not realistic, right? Like, because file systems can be huge, can be network-based or whatever, and going through every inode is not possible. So in essence, this delegation of subranges is always irreversible and persistent, right? Like, it just stays there. If you reboot and come back, files are still going to be delegated. But it's not just that these subranges are delegated to the user IDs. It's also that these subranges are assigned to the container images in an irreversible way. This is just a different way to look at the same problem, right? Like, first of all, you delegate the range to the user, and you cannot get it back because the user can create a SETUID file or whatever to be able to enter it. And then secondly, you assign it to the container, and the container will always have it. So I really dislike this, right? Like, because the UID space isn't even that big, right? Like, that's 32-bit. And if you want to have 64K or something for a container at least, then that just leaves room for 64 containers. And now if you hand them out as if they were nothing to every container and they are persistent, you cannot never take them back, then you will very soon run out of UIDs. So yeah, it just doesn't scale this way. And I don't know. And then the people even started pushing these maps, like this delegation maps, into LDAP SSSD. And it's just like awful. Like, how can you do this? Like, you have an organization that runs, I don't know, Active Directory or whatever those things are called. And like, you have 100,000 users and you want to delegate them each like a couple of 64K ranges to run their containers organization-wide. Like, how is that supposed to work? But I don't know. Nobody asks these questions there. They just do it because it works the way how Unix worked, right? Like, etc pass WD, people think it's a good idea. I think it's a medium good idea. So anyway, it also doesn't nest, right? I mean, this might be a general problem of user namespaces, but it's in particular, you know, the way how this is always fixed, the delegation, and not dynamic, also means you cannot just go and delegate it further, right? Like, because it's also small, and you could never get it back, right? So by nesting, I mean that you can run in a container inside of a container inside of a container, and so on. And then the other thing is, like, you know, even it's supposed to be unprivileged, right? You'll have these weirdly owned inodes in your home directory, right? Like, because you run that container and it gets this delegated UID set, and then it is there, like, with all these files inside of your home directory. But when you actually try to just remove it with RM, no way, you don't get to do this, right? Like, because the file system doesn't know anything about the UID mapping that are applied while the container runs, right? For the file system, like, if you directly from your user ID go to these things, they are foreign-owned files. You just don't get to remove them. The only way to remove them, if you go through your container manager and ask it friendly, so that it does all the dance with setting up the user ID mapping again, calls out a SETUID and so on to the SETUID binary, so that it can remove this. I really don't like this. In particular, as all these user IDs will just show up as numbers, right? So you do not even understand what this is, right? Like there's no semantical information about this. So you just, like if you just use a file browser and look at it, nobody knows what this is, right? Like it's just random files in your directory owned by other user IDs that you cannot actually interact with, but supposedly are yours. So, now I've talked a lot of bad stuff about the status quo. Let's discuss a better world, because we can do this better these days. We know, since the times this was all designed, a lot of things have been added to the Linux kernel, mostly by this guy here in front. But yeah, we can put together a better world now. So how should that world look like? Now, first of all, no SETUID, because SETUID is dumb. And then second is, let's do this with IPC, not with callouts, right? Like, because IPC has this big benefit is that you can have a very isolated operation. That's the one that's going to be executed with privileges on the other side, but you never inherit the execution context, all your security credentials, your UIDs, GIDs, your SELinux labels, and so on, your environment variables, and your key rings, and whatever else, your C groups, and so on, into this thing that's going to execute this. Right, so IPC, great. Callouts that inherit everything, bad. A better world would also mean that we have shorter-lived transient delegation of UID ranges, right? So that when you run a container, you get your user ID range delegated, and when you stop the container again, it returns to the system, right? This has implications. It basically means that this problem that I explained earlier, that the delegations are sticky, needs to be addressed somehow. And it needs to be scaled better, right? Like if I have a user here and I want 500 containers, I should be able to get 500 UID ranges, because there's enough room for this. But if at the same time another user on the same system, I don't know, some container manager in the background or so, also wants 500, should also be able to get this. And if they want 1,000 or whatever, that should all work, right? And the propagation of the delegations, right, of the UID, GID assignments, that should stay on the local machine, to the local boot, and never propagate to other machines. So I think in the better world, SSSD, LDAP stuff should never even consider this stuff, because it should be this local transient stuff that should never be persisted, never be done as an organization-wide thing, like where somebody assigns these ranges. And then the other thing is, of course, like I kind of implied this, no file should persistently be owned by the delegated user ID ranges. And yeah, we have lots of new stuff. ID map mounts, right? Like, so we cannot just run processes with ID mapping applied. We can now mount file systems with ID mapping applied. We have mount file descriptors, right? Like that basically means that we now can set up a mount. You get a file descriptor out for that mount without attaching it anywhere. You can pass that file descriptor around over IPC, and that other thing can then attach it to the file system somewhere, right? That is incredibly powerful, because it basically means you can separate the mounting step from the setting up of the mount table for the namespace environment, right? One thing can run with privileges to get everything ready, and the other thing can run entirely unprivileged. We want modular user space defined security policies, and that we can do now with LSM-BPF, right? Like we do not have to encode everything in a C LSM in kernel and get that merge upstream. We nowadays can define security policies, like restrict access to certain things, to certain operations from user space, but make the kernel enforce it by LSM-BPF. I mean, I hope everybody here knows what LSM-BPF is. Like LSM is like the Linux security module, which like SELinux is one of AppArmor is another one. But you can implement them now in BPF. So you write this down in C code, then you compile it to the BPF, eBPF stuff, you upload it to the kernel, and then can make similar restrictions as SELinux can and AppArmor. There's a question.
So is this roughly equivalent to what we currently use with seccomp, like to have this kind of user space policies, or is that a different layer?
Well, seccomp is a lot more limited, right? Like because it's BPF, like the original BPF, not eBPF, and seccomp is not system-wide. With this stuff, you can basically attach to system-wide to everything. So I'm not sure you can do this right now, but it's powerful enough, I think, to mostly implement SLinux via BPF. I mean, there might be some things missing, and I don't know about the complexities of the operations. But I think, like we have been discussing this a couple of times, like wouldn't it be nice if we could just do this and not have all that stuff in kernel all the time? Yeah. So we have these three technologies, and we can build on this, right? Like this makes a lot of things possible that weren't possible before. So, more specifically in systemd, our first added systemd-nsresourced. nsresourced is a small service shipped with systemd. The way you use it is, first of all, your client allocates a user namespace via unshare or clone. This is exactly the same as before. It's an unprivileged operation. It can just do this. But now, instead of shelling out some binary that is SETUID, the client asks the service via IPC to assign a transient and delegated UID range to it. And that's already it. So why does this actually work now? So the nice thing is the user ID assignments are owned by the client as long as the user namespace exists, and they automatically revert to the global pool once that user namespace dies, right? Like so, for the first time, the assignments are not sticky anymore. They do not survive their use. They survive exactly as long as they are used, meaning as long as the user namespace is kept alive in some way. And that means as long as at least one process is inside of it. So that sounds very, very easy, but of course doesn't answer all these questions about the stickiness. How do we actually enforce that these delegations do not actually cannot actually create files on disk that are sticky, and or allow the user to have SETUID binaries, like create SETUID binaries, so that it forever can get back to these user IDs. The solution to this is, of course, LSM-BPF. I kind of hinted this already. We enforce an LSM-BPF policy that basically requires you to allow list every file system that this user namespace shall have access to. Where access means create inodes, right? Like it will be forbidden. If you try to use your newly acquired UIDs on the wrong file system, you will just get EPERM back. So, I mean, in the kernel, this is bound to this thing that they call superblocks, which is, I still find a very confusing name because superblocks is usually the first couple of sectors on any file system. But in kernel, it's a data structure that just identifies the file system while it is basically in memory in the kernel. So the rule is generally you have to allow list your stuff, and well, okay, I'm a little bit ahead of my slides here. So so by default, if it's not allowed listed, you don't get to write anywhere, right? Except for file systems you actually own yourself, right? File system owning that you can own yourself if you're inside of a user namespace is usually things like tempfs and proc and a couple of others, but there are very few of those, right? Usually the ones that are not block-based. So the reason for this, of course, user ID assignments shall be transient. They shall not be persistent. And creating inodes in a persistent file system, they would lead to persistent storage and would not be transient anymore. So there's a second component, systemd-mountfsd. The second, like the first one, just deals about the user namespace assignments and installs that security policy. The second one is actually about giving access to specific file systems and specific directories to that user namespace. It's also a very small service shipped with systemd. It provides one API call. You pass a file descriptor to some file that is a DDI to it, together with a user namespace file descriptor. And then the service does a couple of things and then returns you a mount file descriptor, which maps whatever is in that DDI to your user namespace, right? And then, the user IDs that we expect to be used on disk in the DDI are 0 to 65535, right, like the lower 16-bit. But the but it's going to automatically be mapped to the range that your user NS is using, right? So, and the trick is, this new mount, as it's created, is automatically allow listed in systemd-nsresourced. So if you go through mountfsd, you can add additional file systems you want to have access to your user namespace. So let's look at how an algorithm would look like from a container manager perspective to actually make use of this. as before. You allocate your own user namespace, then you go to nsresourced and ask for a delegated user ID range, and then you go to systemd-mountfsd, pass the file descriptor to the DDI and the user namespace, and then you get your mapping, like your mount file descriptor back, and you can attach it wherever you like. That's already it. It's actually really, really simple, right? Like one syscall in its essence, 2 IPC calls. And yeah, but DDIs are great, of course, right? Like because they can be signed, and I love them and everything. But of course, not everybody wants to use DDIs. If you want to run stuff from a plain directory, then things get more complicated. So in systemd-nsresourced, we also cover this, but it's a little bit more complex because the good thing about DDIs is that they're isolated from the host system, and we can just never give anyone ever access to the unmapped version of that DDI. But for plain directories, this doesn't work, right? Like because a plain directory, if you own that plain directory and you want to have that mapped, then of course you have that plain directory. You can always access this. So this creates complexity, but we deal with this. We'll see how. There's another API call in mountfsd. Actually, that was supposed to say mountfsd. You basically pass in a file descriptor not to a file that contains a DDI, but a file descriptor to a directory you want to have mapped. And then the same thing basically happens. You get back a mountfd with the user ID mapping applied. So, but the question is, a UID mapping from what to what precisely? So, for that, we defined basically a new specific fixed UID range that we call the foreign UID range, and it's that range. It's like 64 64K UIDs. And this, the idea is basically that you can have container images wherever you want them, and if they are owned by that range, right? Like so that the root user inside of it doesn't use user ID 0, but uses 21573525676, right? Then we consider them owned by this specific foreign user ID range, right? This is a constant. This is the same for everybody. There's no distinction made, right? And if that exists, right, then we'll set up. And you ask for it like with one of those directory file descriptors to get a mapping for this, then we'll map that user ID to whatever is assigned to your user namespace, right? So a common 64K UID range that container images can be owned by, but only on disk, right? So this gets a little bit confusing now, right? Like first of all, we have the runtime transient user ID mappings, and now we have the special range, which is about just persistent on disk, right? And we create the mappings between them. So, just to say what I just said, like to emphasize what I just said, this range is constant. It's fixed. It's the same for everybody on any disk. This user ID range is never used for anything else, right? You cannot, the idea is that you cannot actually run a process with those user IDs in use, right? Like it's only supposed to be the passive thing for stuff on disk, that to actually run something off it, you always have to map to a transient user ID range to actually make use of it. Yeah.
Question. You said you can never run a process with this. Do we enforce it,
no.
Or is it?
But we should. It's one of, in my talk yesterday, I talked about these universal truths, and I think it's one of these universal truths we should enforce, that whenever we see something doing a set UID call, system call, or an equivalent, via LSMBPF, we should just say, no, sorry, this is like off limits, this is only offline stuff on disk. You can chown it, that's fine. You can never set UID your process to it. Let's talk about that algorithm from the container client's point of view again. Now we run a container of a directory. So we do the unshare clone thing again. We ask for a delegated runtime UID range. And then we go to mountfsd and ask for an ID map mountfd from that foreign UID range directory to the delegated UID range. And that's already it. Now you have these mount file descriptors, you put them wherever you want, and there you go. So there are a couple of but ifs though, right? Like, and it's not all that easy, right? Because we have to enforce certain security restrictions, because otherwise you could take somebody else's directories and do stuff with them, right? So for DDIs, we declare they have to be signed, right? Like they must be, like they cannot just be DDIs with a simple file system in them. They need to be DDIs that come with verity information and a signature on it. Because only then we can be reasonably sure that if your OS recognizes the signature, we can be reasonably sure that the file systems inside of those DDIs can be trusted and are not rogue file systems that exploit the kernel. Because I hope this is well known. The kernel file system developers generally declare that they do not consider it a problem if, like at least not a big problem, not a security issue, if a rogue file system can take the kernel apart, right? Like so that you can exploit the kernel by mounting untrusted file systems. So we declare the DDIs must be signed. And the signature for that needs to be recognized by the kernel, or like we also have some user space support that if we can't get a key into the kernel keyring. But yeah, the essence is basically, this is quite limiting, of course, right? Like because it means that you cannot just prepare an image, sign it with your own key and get it applied. You also have to install that key into the keyring. Yeah, the signature stuff, of course, does not apply if you do the directory stuff, because, I mean, how could it even, right? There is no concept for signing that stuff. By the way, if you have a DDI and it's not signed, or it's signed by an untrusted key, right? The way what actually happens is that you will get a policy kit prompt to sign off on this anyway, right? So it's not a complete failure. We will not just say, no, go away. We will say, we will just say, we will not give you this without authenticating as a super user, but if you do authenticate a super user right now, we'll give it to you anyway. Then the big question, of course, is, so now you want to have this container tree in your home directory, and you want to have it owned by the foreign UID range. So how do you actually get there, right? Like, because you cannot just do mkdir and then chown to that foreign user ID range, because that's still, like, this is not allowed by the Linux kernel. So systemd-mountfsd has an API for that, where basically it's called make directory, right? Like you specify a file descriptor to wherever you want to have that directory created, specify a name, and then the service will create it for you, properly owned by that UID. Future systemd-import-d, I have a PR open for that. We'll just set it up like this automatically. Running a container is usually not just having a user namespace set up and having a couple of mounts in it. It usually also means you want some other resources to in. Like there's C groups, for example. So nsresourced actually has an API for this, so that again, it get a delegated C group, like sub C group, to whatever you are running in that is owned by the foreign user ID, right? So that you can actually run full OS containers. And then something similar is you can also get a delegated network interface that you can just ask systemd-nsresourced to give me a network interface, and we'll create a VHDH tunnel or something for you. And by default, we configure network D to the other side, so it's just going to work, right? To put all of this together, the complete algorithm for a container manager could be: you do your system call to get the user namespace. You do your call to systemd-nsresourced to assign a UID range to it. You go to systemd-mountfsd to ask for attachment of a couple of DDIs and directories to it. I mean, you can ask for as many as you want, actually. I mean, we will put a limit on things, but you do not ask for 1 million. But ultimately, like, conceptually, you can ask for as many as you want, so that you can put together complex stuff, right? You can have a container where the, I don't know, /user comes from a DDI and the root of S comes from a directory or whatever else you want there. Then you ask for a delegated C group via nsresourced, and then you ask for a network interface or so. You can ask for multiple network interfaces. You could even ask for multiple C groups, but I'm not sure why you would do that. And that's it. So it just works. So the net results are: all delegations are transient. They revert back automatically and auto-destroy if a client dies, right? Like, so for the first time, we have a very clear life cycle. You pin your delegation of user IDs via the lifetime of the user NS, and because user namespaces on Linux can have a file descriptor pointing to them, you have a really nice handle to the delegation, right? As long as you have a process or a file descriptor open, this thing stays around, and if you close it, it's gone. The user ID ranges never hit the disk untranslated, right? Either they are mapped to 0 to 65,000 in the case of DDIs, or they're translated to the foreign user ID in the case where you back it by a local directory. Yeah, this is what I'm saying here again, like same thing. And writing anywhere else, unless it's a file system your user namespace actually owns, like a tempfs, it's prohibited. The clients are entirely unprivileged, no SETUID nor anything, no callouts, nothing. If you run 500 concurrent containers, they can all have their own range. They will be nicely isolated during runtime. This means it scales quite fine, right? Like it's just a couple of system calls, and there's no limit on, like, I mean, there is a limit on how many you can have delegated because they are only 32-bit in a UID. But yeah, it's not perfect. There are a couple of uglinesses. I complained earlier about the fact that there are, in the classic model right now, there are foreign-owned inodes in your home. They still are, right? It's a little bit nicer, though, because at least they are always owned by the same UID, and we give it a nice name, right? Like you will see it as showing up as foreign-0 for the root user, right? Which I would say is not great, but at least it's a step up. And you can actually, the nice thing is you can actually have it in your home directory, and you can move the home directory between systems, and it will always make sense, right? Like because it's not dependent on what you got delegated, because it's the same thing for everybody. It currently doesn't nest either, but mostly because I have been lazy, not because it couldn't, right? Like because, one of the things that I keep saying about Varlink is that it has this delegation thing where you can mount the entry point sockets into some containers. So we can deal with this. I didn't, but at least there's a clear avenue how to get there. In Ansible, it's implemented. It works for, like, it could be used by any container manager, and it's actually really simple Varlink IPC call thing. And that's all I have for now, and maybe I have a little bit of time for questions.
So a very common use case for unprivileged containers is to share files from your home directory with the container so that you do operation on them. How would you do that with this model?
That's a very good question. Actually, so the model is a little bit more complex than I was explaining here. We do allow some certain other mappings as well, but they're very restrictive. So basically, you can map only the foreign user ID and your own to whatever you else, to your user ID namespace. And that's just your answer, right? Like you basically can say, I want this directory that is owned by foreign UID as the base, and then I want also this directory owned by yourself also mapped in, and then you get to have that. So it's covered.
To what way could that integrate with the existing sub-UID stuff? Let's say you have Podman that needs this new UID map. Could it be configured that it doesn't allocate stuff that is already defined in the sub-UID ranges normally?
So this stuff is like nsresourced before it actually assigns a subrange to you. It's relatively careful about making sure that it's not used before. Like, it really depends. Like, if we can figure out it's used, and there are a couple of ways we figure this out, by a quota and by checking NSS, then it works. But I'm not sure if Podman does any of this. But if they don't tell us that they're using this, we cannot possibly do this. But we define a very clear range, right? Like it's spec'd out. It's on the website, so people should know this is how this works, right? Like, and we have a log file so that this is actually properly serialized and everything. But yeah.
All right. Thanks.
A couple of questions. These files that land in your home directory, how do you delete them?
Yeah, well, as mentioned, it's not perfect, right? Like, it's the same thing. You have to ask somebody else. But at least, this way it's generic, right? Like, because these files are going to be owned exactly by the foreign user ID range. So we can give you a generic tool that whenever there's a file where, if you go up the path, there is some directory that is owned by you, we can allow you to delete it, right?
And could I mark these files setuid, for example, and then become one of those strange UIDs?
You cannot, because they are owned by the foreign user ID, not by you.
Yeah, but if I like from the container, I put a file there, I mark it setuid to root inside the container, then outside of the container, I could also become that UID.
No, because we disallow creating SETUID files for this kind of stuff.
Okay, and then maybe like a more general question. This all seems very complicated, and maybe it would be simpler if there was some mechanism in the kernel to hand out anonymous UID ranges. Do you know the work that like Stefan Graber was doing?
Yes, I'm aware of that, but it kind of stalled.
Do you know if that went anywhere, or?
Ask Christian here. Like the stuff that Stefan did regarding like detached user stuff.
So the 64-bit UID, it's an idea we came up with years ago. That could be made to work. I've seen the patches that exist for this. There's one big problem with this, like it blows up every struct that embeds a KUIDT in the kernel by 4 bytes. This is a serious problem of this idea, and also it's kind of ugly because like right now if you have a KUID in the kernel, where it comes from is completely irrelevant, right? Like it doesn't matter. It's just a KUID. It's self-explanatory. It carries its own privilege. If you essentially need to mark it as being from a specific user namespace. So suddenly a KUIDT is like not, it's a type in a kernel, it doesn't matter. The UID as used in the kernel is not self-explanatory anymore. And you always need to make sure that you carry this additional information around. As I said, like it's a great idea. We always thought it would be easy like to make it work, but like there is still some issues to solve.
Yeah, but I do not agree that this is complex, right? Like, it's just very simple IPC calls, right? Like, you get your user namespace, you ask for the delegation, you ask for the resources you want to be assigned to it. I think every programmer who is able to write a container manager should trivially understand these parts, right? It's probably simpler trying to do this with, like, shelling out and doing this securely. Okay, I didn't understand that, but yeah.
Back to you.
I just wanted to say, like with the implementation using BPF LSMs and all of this stuff, it seems like having something in the kernel for this just seems like it could be a bit easier somehow.
Yeah, I mean, I was very conservative with all of this because I kind of wanted that the kernel people solve this for us. They never did, and I think there are certain problems with requiring that, right? Like, because as long as you do not do this stuff that Stefan suggested, then you need some component that manages these delegations in user space. You cannot get away from this, right? Like, so I think this is like the code base for this is actually really tiny, right? It's because the kernel added all these concepts like mount file descriptors, ID map mounts, it can be relatively small in user space. But as long as we have to manage these delegations, there's always be a user space component. That's it. So I don't know. Like, I think could it be better? Maybe, but I wouldn't even know how. Like, except for the Stefan thing. But I think it creates other problems too that we need to answer.
Do you have some idea how you could potentially solve this problem of foreign known files in your home directory? Could you do some ID mapped another layer of ID map mounting or something to make them owned by the?
I mean, you could also have the directories owned by your own user ID, right? This will get you to some point because, for example, in /user, at least to in my religion, I would always say in /user all files should be owned by root, and if you map that root to your user, then everything's fine. But also, like, if you run full OS containers, you want more than one user ID inside of that container, right? So you need to map those somewhere, and you cannot map them to all the same user because that's not how user ID mappings work, right? Like, they need a bijective mapping, right? You cannot map one user to many or many to one, right? So for specific cases, yes, you can do this, where you basically say everything that I have on disk is just one user ID and then have a tempfs for everything else. But then this would also imply that all your containers are ephemeral and just you start them up and then whatever they write to the disk goes away when they go away. But yeah, for the general picture, I don't think this works. Like, I don't have an idea, but Christian might. Okay.
Did Christian want to comment, or?
He just wanted to comment.
Okay.
So one thing that I worked on and that I had a POC for is like with IDmap mounts you can do exactly that, like that you can squash UIDs and GIDs. Like for example, say squash it all down to a single UID, or even have like where ranges map to a single UID and so on. It's actually not that complicated. It was just a matter of
but it would have weird semantics, right? Like occasionally you create a file, you tune it to one user, and when you read a stat, it might be owned by a different user, right? Like because then it needs to translate it back.
I don't exactly know how I did this anymore, but it's I saw like it's very much like is it VerdaIOFS? VerdaIOFS does it, I think, that allows like range squashing, or it's.
I mean, VFET does, right? Right, like you create something as your user ID, and it's when you read it back, it's owned by something else. So I mean, yeah, it certainly.
But we could do this, and we could come up with like I think semantics that are sane and not completely strange for user space.
Last question, and sorry, he was first. Sorry.
So you mentioned we could fix the problem of removing foreign UID owned files from your home directory if you walk up the tree and check if you find the directory owned by the current user. But
yeah, that's a security policy we always enforce, right? Like we only allow you to map directories owned by the foreign user ID if we can find at least one parent that is owned by you.
Yes, but so my question is, can we do the opposite as well? Can we change a directory tree owned by the current or like by your own UID to the foreign UID range? Let's say I have a container rootfs all owned by my own user. Can I change the UIDs all to the foreign UID range without having to be root?
I mean, I wonder like, sure. I mean, I see no reason why we couldn't allow that too. But yeah, we could. That should be fine.
That's all the time we have. Let's thank Lennart. Thank you.
Thank you.